Good evening for all of you. Am I audible? Oh, very good. So let us move to the further. So last session, we had a discussion related to method overriding, which is associated with the polymorphism very closely today. So let us enter into the discussion called polymorphism in today's class. So let me show you the method overriding once. Method overriding, which is a very close to the polymorphism. I can say it is a polymorphism indirect related examples. Let me open it here. Class method overriding is one of the distinct programming feature of Python. To use method overriding in our Python program, we must use inheritance principle. Definition of method overriding. Method overriding is equal to method heading is same plus method body is different. So the process of redefining, one more definition I wrote it here. The process of redefining the original method of base class into various derived classes for performing various operations is called method overriding. Okay. The process of redefining the original method of base class into various derived classes for performing various operations is called method overriding, we can call. So ultimately, we understand the scenario called what? Method overriding require compulsory inheritance principle. Now, I hope that this is the topic in yesterday's class. And today's class is very, very simple. This concept related inclusion topic is using, that is called polymorphism principle. We are going to use it. What is the topic name? Polymorphism. We are using polymorphism in Python. Polymorphism in Python, we are using it. What exactly this polymorphism in Python is? Very, very simple. Very, very simple. So, Omkar, method overloading in Python is there or not? You only need to tell. Method overloading is there in Python? Is there or not there? Is there or not there? Method overloading is there or not there? Come on, fast. Constructor overloading. You see, constructor overloading. What is meant by constructor overloading? Constructor name is same, but whose parameters are different is the meaning actually. Java supports method overloading, but strictly Python is not going to support that much. We cannot write two constructors in the same class. We cannot write two constructors in the same class. But where do you write it? How we have written that, and you have seen in the class virtually. We have seen in the class. We have written only one constructor, which is taking default parameters and all those things. Did you understand that or not? Constructor. We wrote two constructors or only one constructor? Have you written only one constructor or two constructors? Only one constructor. So constructor name is one only. We written two things which will satisfy the property of default as well as parameterized. Yeah. So let us today, we are talking about polymorphism, which is a very, very simple thing. So let's start with the polymorphism. Yes. Yeah. Next, let us start with the polymorphism. I will address once again, Omkar. Once again, I will address that point in the class. Okay, na? Once again, I will address. Polymorphism is one of the distinct feature of what? Distinct feature of oops. Sir, what is this purpose? What is this purpose? You can say Definition I will give you. Definition I will give you. The purpose of polymorphism is to utilize the minimized memory space. To utilize the minimized memory space. Right? I will write the purpose. I will write the definition also. 1 minute, you just follow me. I will write the purpose. I will write the definition, and the definition analysis. I will go for it. Let us take one small general knowledge question. One small general knowledge question. So he is a person. He is a person. He is a person. Assume. Take one small example. Take one small example. General knowledge example. This is. Take this person name. Who is called X? Who is called X? X is called a person. He is called one person. Okay. So he is sitting in our class. He is sitting in our class. He is sitting in our class. So he is what? He is sitting in our class. Who is this person called? Can anybody can say? He is a student, right or not? He is a student. He is a student too. My dear students, when you are sitting in my class, you are called a student. The same person is going to the home. He is going to the home after the class is over. He is going to the home. He is called what? Family member. He is called son or daughter. He is called son or daughter. Right or not? Right or not? Son or daughter. Now the same person is going to the state movie. He is going to the movie. He is going to the movie. Students, please carefully understand. When he is going to the movie, he is called an audience. He is an audience. He is an audience. Carefully watch it. He is an audience. When he is going to the stadium, he is going to the stadium. He is going to the stadium. Who is this? He is a player. Assume that. He is a player. He is a player. Same person is going to the shop. He is going to the shop. Shop. He is a customer. He is a customer. Same person is going to the battlefield. Battlefield. He is the same person is going to the battlefield. Who is this person? Who is this person? This person is going to warrior. He is a warrior. He is a soldier. You know, soldier. He is a soldier. He is a warrior. Now tell me, who are all these things? One person is a person having different behaviors are there. What do you understand this? How many people are there with you? How many people are there with you? One person or more than one person? Is a one person or more than one person? He is a one person only. One person. He is called one person. He is called one person. Having how many behaviors? Having what? Multiple behaviors he is having. So, actually, original concept of polymorphism is the process of representing one form in multiple forms. The process of representing one form in multiple forms is called polymorphism. Is called what? Polymorphism. Actually, students, it's a very beautiful example. That is the process of representing one form in multiple forms is called polymorphism. The process of representing one form in multiple forms is called polymorphism. I will give you that. So, next, let me go for the example. Let me go for the technical example. I will give you technical example. Students, you see, this is called a Oracle database. This is called a MySQL database. It is called a MongoDB. It is called a DB2, etc. Databases are there, which you have already observed it. Oracle database. It is called a MySQL database. MySQL database. It is called SQLite 3. SQLite 3. SQLite 3. And the next is called, it is called MongoDB. MongoDB. This is called MongoDB. MongoDB. Now the Python programmer want to execute, now Python programmer want to connect to the database. Just tell me to connect to the database, what function you are using, ma? Which function you are using? Yes, everybody, already you are aware of it. Which function you are using? Connect function you are using. Are you changing this connect function? You are using which function? Connect function you are using. You know what are the things you are passing. Even in all the databases, you are using the same function. In all the databases, you are using the same function, connect function. You are using here also connect function, connect function. Next, here also you are using connect function. What is the function? Function is called one or many. Is it one function or many function? One form. He is using for how many forms to communicate? He is using for how many forms to communicate? Multiple forms to communicate. But what is different? Modules are different, no doubt in that. So one function is communicating with multiple databases. One function is used for communicating with multiple databases. So there we are using internally the most of the Python software related library implemented with the OOPS features, that too polymorphism is using many of the places. So because of this one function dealing with many things, it is easy to remember. That is the first activity. Second one is called what? Taking the minimized memory space. Minimized memory space it is taking. Suppose if you take X function, then Y function, Z function, and then what? K function if you take it, if you take these many number of functions, it is difficult for the programmer to remember. If you have hundreds of databases, hundreds of functions, if you remember, it's very difficult. For the people to remember. That's why one function is easy to remember. I hope that you people are understanding what is the meaning of one form in multiple forms. So can I write the word called what? The definition of polymorphism. I'm trying to say definition of polymorphism here. I will explain definition of polymorphism in detail. Definition of what? Polymorphism. Definition of polymorphism. What is the definition of polymorphism? Very, very simple, students. Definition of polymorphism. What I'm writing, try to understand my point here. The process of representing, carefully understand, the process of representing one form in multiple forms. The process of representing one form in multiple forms is called the process of representing one form in multiple forms. I will write on the top of it. One form in multiple forms. Is called polymorphism. Is called what? Polymorphism. The process of representing one form in multiple forms is called what? Polymorphism. What is meant by this one form? What is meant by multiple forms? Look at that, all of you. One form in multiple forms. What is one form? What is multiple forms? I am going to give you the clarity. Let me open yesterday's class. Let me open my yesterday's programming method overriding. Take that programming. Their inheritance you take it. Method overriding example 1 and 2. 2 you open it. Yes, it is a constructor. Let me open the third one also. Once you open third one, carefully understand, students, everybody. In this place, let me give you one small diagrammatic representation here. This is called a circle. This is circle. What is the function I am having? Area function. You have area function. This is called what class here? Yesterday's class. Rect class it is. Rect class. Of course, 1 minute. 1 minute you wait. 1 minute. It is a multi-level I am using. Rect class I am using. In rect class, what you did, you are inheriting this area function and you are overriding that function. Overriding, inherited, and self is there. Self you have, here you have self, and then you are overriding this, overriding. See guys, all of you, and one more function, one more class also I will take it. What is my class here? Square function you take it, square class you take it. Again this area function, again this area function is coming. Again this area function is coming. What you did there? What you did? You are overriding that function once again. Overriding with that logic. Tell me, in all the places, when I am executing circle, this area function is taking. When I am executing this area, previous memory space is occupied with this memory space. I got the result here, and previous memory space occupied by this current execution function, because same function. And this result I got it later, that memory space is occupied by this memory space. At any point of time, only one memory space is taking in the main memory, not taking three memory spaces. Tell me, it is called a original method. Original method. Original method. Original method. And these are called overridden methods. Overridden methods. This is called overridden method. Ultimately, tell me how many methods I have. Carefully think. Carefully think. No, careful, careful. One function only there. One form only available. But how many forms you are preparing? How many forms you are preparing? Two forms you prepared extra. Extra you prepared two forms. Totally three forms are available. Actually, originally only one form is there. But the same method you have overridden and you are showing multiple forms. It is nothing but the process of representing one form in multiple forms. The process of representing one form in multiple forms is called overriding, method overriding. The process of representing one form in multiple forms is called overriding. Sir, what is the original form? One form is nothing but which method? One form is nothing but which method? Original method. All of you must respond, ma. Multiple forms are nothing but what methods? Overridden methods. Multiple forms are Did you understand? Did you understand, student? All of you? Yes. Come back to the point back. Come back to the point. If you observe this diagram, it is one person only, one form only, but these are all called what? If you carefully see, these are all called multiple forms. He is called one form. He is called original form. And later you are represented like this. Later you are representing. Depends on the situation. You are having one memory space only. See how easy it is. One memory space only, but you are giving different answers here. That's why polymorphism real-time implementation is, it provides internal inbuilt less memory space will be utilized. Less memory space only will be utilized. So let us go to that and try to understand here in the definition of polymorphism. In the definition of polymorphism, one form, I'm writing students, one form is nothing but original method. Nothing but what? Original method. Original method. And multiple forms. And multiple forms is nothing but, multiple forms are nothing but what? Overridden methods. Overridden methods. I'm saying that overridden methods. Overridden methods. Multiple forms are nothing but overridden methods. Is it understandable? What is meant by form? I will write it. One form is nothing but original method, which is defined first time. Multiple forms are nothing but overridden methods. What is the form? A form is nothing but, see students, a form is nothing but, in the polymorphism I am talking about, a form is nothing but state of existence, state of existence. What is meant by that, sir? If the method exists in, if the method exists in which class? Base class. Then it is called what method? Original method. Original method. Original method. And if it is existing in, and if it is existing in, if it is existing in which class? Derived class. If it is existing in derived class, then it is called then it is called overridden methods. Then it is called what methods? Overridden methods. Overridden methods. A form is nothing but state of existence. If a method is existing in base class, then it is called original method. That is called one form. If it is existing in derived class, then it is called overridden methods. Is this a definition, and is the definition and analysis of the definition is clear, my dear students? All of you, everybody must confirm it, guys. Fine. Perfect. And one more announcement I want to give it. Tomorrow we have a class, because tomorrow we have a class. That is Sunday. Sunday we have a class. Tomorrow means Sunday. Sunday we have a class. At 7 a.m. 7 a.m. I will take. So because in the tomorrow we have the class at 7 a.m. because I already told you, after the SOOPS features, we are having multi-threading, and the next is called a regular expression topic is there. Regular expression is an important topic for you that I want to start on Monday. Monday I will start. So tomorrow I will complete. So after this polymorphism, data abstraction, data encapsulation, of course that is very simple. So tomorrow I want to take this data abstraction, data encapsulation related information I want to explain. So Monday regular expressions I will take it. Regular expression I want to discuss. So we should not miss it. Regular expression I will explain in Monday class. That will take Monday, that will take Tuesday, and Wednesday. So very powerful topic. 3 days it will take. If you understand easily, 2 days it will take, because most interesting and very, very powerful thing. That is regular expression. Next term, multi-threading is there. Multi-threading. Actually, these are new topics I'm telling students. No Python batch people will be having these things, right? So it will take some 4 days. It will take. Okay. So this is the action plan of my class session. Action plan of it. There is one more programming also I want to tell you. Network programming I will take up. So this I will take it. This will take 2 days, because this is no use at all as on today. So in every batch, network programming I will teach in Python. Okay, there is no use because we have a Django in place of it. It was a olden days style. I used to take in every batch as a last topic. So this is an action plan. So this is the most important. Multi-threading is the next important, so that this will be done as a part of the Python course will be completed. So 3 days plus 4 days, 7 days, plus this 2 days I will take coming Sunday also. Tomorrow I will take. Coming Sunday also I will take the class. Right? One more day it will take for us. Okay? This is our action plan. So the most probably it will take next Monday. This is our next Monday. I may complete not coming Monday, next Monday, that is 20th, my class will be over. If anything, of course, if you add this is going to lead to 21st, right? Fine. I will be talking about some 20th. If not completing, coming Sunday, I may take the class. So I will teach everything for you and be perfect in this area. This is the area of the programming I want to teach it. Okay, students. So Django also I will teach ma. Don't worry. Django also I will explain. Django also I will. There is a separate course, students. Separate course. Django also separate course. Yeah. So because new batch waiting, many of the students are waiting, and management has given a notice today. There is they send a information, new batch slot they are asking me to give it. So anyhow, this is a batch which we need to give it. So this is an action plan. So tomorrow I'm taking the class. Yes, I will tell you that when the Django batch will start. At the same time, please ask in the office. Please ask in the office once so that we can move forward. Okay, right. So I think this action plan is clear. Let us coming to this program here. Yes. Yes, ma. We will go for it. Right. If anybody was absent for any of the classes, you can utilize my 9 o'clock. You can utilize my 9 o'clock. Meena Kumari. Yes, ma. You can utilize my 9 o'clock, dear students. If anybody was missing my class, you can utilize my sessions. When you go to AI, machine learning, deep learning, those kind of modules will be explained there only. Because Python is coming. Suppose, John, I'm saying to you, see, in this Python programming, whatever the modules we covered, that is programming related. If we come to artificial intelligence, like there is a machine learning, you take it. There is a module called what? Decision tree. Like that, so many number of decision tree, like supervised learning, unsupervised learning, reinforcement learning. There is a separate algorithms are there. So those faculties will use this type of Python programming. They will utilize the library. Like in Java, core Java, advanced Java, like that. In core Java only, we don't discuss advanced Java kind of packages. Okay. I hope you are understanding technically. Right. Fine. Yeah. If you attended NumPy and Pandas, no problem. Narsimha, it is sharp and attended, no problem. If anybody was missing, you can attend my 9 a.m. class also by taking the link from the administrators. No problem. You are most welcome to come to any of my sessions. Provided you need to take the, no problem. You are most welcome. Once I will give my number also. Please contact the administrators. Try to get the link details. So you are most welcome to my classes. Okay. Anytime you are most welcome to my classes. If anybody was missing in your sessions. Okay, students. Right. So coming, you're most welcome. Anybody missing the classes, you are most welcome. From the bottom of my heart, I am welcoming you to attend the sessions. That's what I'm saying. Don't miss the single session of mine. Okay. Let us coming to the topic part. So coming here, polymorphism is nothing but process of representing one form in multiple forms is called what? Polymorphism. Yes, ma, Kotesh. Yeah, that things will be there. Data analytics is in the form of data science. So that kind of thing, all those things, yeah, that will be a part of our data science. Okay, fine. Now let us coming to the continuation part of this thing. A form is nothing but existence. If the method exists in base class, then it is called original method. If it is existing in derived class, then it is called overridden methods. Dear students, if I come back to these statements, coming to the programming part once, programming part you come. Last class, what we did, one program, I will open it. Let us see. In this case, there is a circle, draw method. Again, the same draw method is available. Again, the same draw method is available. What do you understand here? What do you understand here? Draw method is called which method? Original method. What is this method is called overridden method. What is this method is called overridden method. What do you understand? How many draw methods are there technically? How many draw methods are there technically? So three draw methods are available. Three draw methods are available. When we have three draw methods, definitely one draw method only will be the main component. Same draw method we are going to override. That means technically speaking, only one draw method and other things are called overridden forms. Overridden forms. Right. So in this case, the polymorphism concept is resembling or not. In this case, you see polymorphism concept is resembling or not. That means polymorphism concept, will you observe it in this place or not? Yes, we have the polymorphism concept here. We have the polymorphism concept. So this line number 3 is called one form and line number 7, line number 11 are called multiple forms. Am I correct? Am I correct, students? Yes. Fine. One more thing is here, method overriding example 2 you see. Method overriding example 3 you see. Area method is available. Again area method is available. Again area method is available. How many area methods I am having actually? Strictly speaking, how many area methods I have? Only one area method is there. Only one area method is there. But how many area methods we have overridden? 2 area methods are there. And how it is see students, how it is a minimized memory spaces are. See students, very important point. See SO dot area square, it will come to square. So internally we will have the memory space created. We got the answer for square related area. You are calling super dot area. It is coming to this place. Do you know what is happening? Whatever the memory space was available, whose result we got it? It was utilized by the same area method for executing some other kind of logic of rectangle. Here also we got the answer. Super dot area, when you call it, it will come to this area function. Previously getting result is overlapped with this kind of result. That means in how many memory spaces I am getting 3 answers? In how many memory spaces I am getting 3 answers? In one memory space, I am getting 3 beautiful answers, 3 beautiful outputs I am getting. Hence, are we getting less memory space or not? See that, the most important purpose I would like to write. The purpose of the internal purpose of polymorphism, the internal purpose of polymorphism, the internal purpose of polymorphism is that to utilize what? To utilize less memory space. To utilize less memory space. The internal purpose of polymorphism is that to utilize a less memory space. Instead of less memory space, I can use to utilize minimized memory space, and it results effective performance, and it results in effective performance. I hope you are understanding what I am trying to tell. I hope you are understanding our effective performance. Right, students? Effective performance is provided because of this memory space. And one more thing is to implement this polymorphism. See, students, implement means what? to bring into action. What is the action format? One form in multiple forms if we want to bring it. What is the definition of polymorphism here? See that in the definition of polymorphism, where is the definition is written? The definition of polymorphism, I forget here. Definition of polymorphism, where is the definition I wrote? Okay, it was written. Okay, good. The definition of polymorphism, here it is written. The process of representing one form in multiple forms. The internal purpose of polymorphism is, this point I will write on the top of it, so that it is more equally we are saying. Yeah. Now, utilizing minimized memory space, that is the most important word to say. Okay. So to implement means bring into action. To implement a polymorphism concept, we use which concept? To implement a polymorphism concept, we use we use method overriding. Yesterday's class also, mono, schema, mono. We use method overriding. And method overriding uses, and it uses, and method overriding uses. Yesterday's concept only we discussed it. Schema, method overriding, yesterday's class. Method overriding uses. To use a method overriding in Python program, we must use which principle? Inheritance principle we are using. To use a method overriding in a Python program, we use inheritance principle. Ultimately, you tell me, guys, to implement a polymorphism, we use method overriding. And to use method overriding, in our Python program, we use inheritance principle. Indirectly tell me, polymorphism uses what concepts? Polymorphism uses which concepts? Inheritance we are using, method overriding we are using. Tausif, very good. To utilize this polymorphism, we are using method overriding actually. Method overriding uses polymorphism. In simple word, I will write in the note point if you want. If you want, I will write it. Polymorphism uses what? Method overriding uses inheritance principle, students. Inheritance principle. I am writing here inheritance principle. This is a point you must remember here. Inheritance principle, we are using it. So polymorphism principle uses method overriding. Method overriding uses inheritance principle. Compulsory. I hope, dear students, you understand this entire words. Is it clear? Now, yes, Omkar, you are getting a doubt about utilize the minimized memory space, you are saying. Omkar, is the other students understand the word called minimized memory space, ma? All of you? Is it understandable? Tausif, okay, good. Right? Not a problem. I will give you the clarity for you. No problem at all. Nothing to worry about it. I will give you the clarity. Look at, you will get immediately to full clarity will come. You take it. This is called one class. 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 What is my class here? Circle class. Circle class. I am taking only inheritance, ma. Only inheritance. Only inheritance I am taking. This is called a rectangle class. And this is called what you know. This is called what you know. Square class I am taking. Square class I am taking. This circle class contains area method, circle area, CIR area, and this is containing rect area, and this is containing SQ area, square area, SQ area. This is called SQ area. Now it is applied inheritance. Definitely, students. This is called strictly inheritance. Inheritance. So tell me which object I am creating. SO is equal to square you are creating. Square you are creating. What is happening? SO dot SQ area. That means one separate memory space is created for that. And next one more I am creating SO dot rect area. Rect area. One more memory space is created. Next, one more function is one more things is there. SO dot circle area. One more function is available here. Tell me how many memory spaces are created? How many memory spaces are created? 3 memory spaces are created compulsorily. This is called inheritance. Very good. Same type of diagram. Same type of diagram. I would like to take it, students, and observe it, all of you. Carefully try to observe it. In this case, try to observe very carefully. What is my diagram here says? What is my diagram says? I am taking here, yes, here area method, here rectangle method, here SQ. This is the methods I am having. What is happening here? Area method, original method, this is original method, OM, original method. Here it is called what? Overridden method, this is called overridden method, ORM, overridden method. This is called overridden method. This is also called overridden method. Okay. Now we are saying what here? Superfunction dot area. I will explain superfunction also. Where to use, how to use it. It will come to this area. I will write from here. I will call it as what? Super dot. What is this now? Area. Now here you tell me SO is equal to square. Dear students, carefully observe area. What is happening? When you go for this SO dot area, it will go to where? It will go to this place. Yes. It is executing. It is executed. That means in the main memory, it is allocated some memory space. In that memory space, it is executed. I got the answer of what? Square area. And you are calling super dot area. So PVM control go to this place. And what is happening? Same function, it is eliminating the existing memory space, and then it is existing result is eliminated, and it starts executing again in the same memory space only. Omkar. Executing in the same memory space. This result is coming. Again, you called super dot area. It will go there, eliminate the total result in that memory space, again executing with a new logic. This result is coming here. In the same memory space, 3 results are coming. In the same memory space, 3 results are coming. So here, how much memory space? 3 different memory spaces are taken. 3 different memory spaces are taken. 3 results separately coming by creating 3 memory spaces. Here, how many memory spaces I am getting? 1 memory space I am getting for all the 3 methods. Are you understanding, students? Is it understandable or not? Omkar, is it clear? Yes. So which one is better? In this place, polymorphism is there, inheritance is there. Once polymorphism is there, means all will come. Classes are there, objects are there, inheritance is there, polymorphism is also there. Everything is there inside of it. I hope you are understanding what I am talking. Okay, students, shall I show you that example? Now you see one more kind of thing, student. You see constructor example, once, constructor related example, you see constructor. It is called which one? Original method, original constructor. What you did here? Overridden constructor it is. See that overridden constructor. How many constructors are there? 1 constructor only. Available in how many forms? 2 forms. One in many forms. One in many forms is called which concept? One in many concepts is called which concept? One in many forms is called polymorphism concept. One in many forms is called polymorphism concept. So in this case, method overridden is there, constructor overridden, but hidden principle is called what? Polymorphism. Hidden principle is called polymorphism. I can say in today's session, so to implement the polymorphism concept, we use a method overriding. And to use a method overriding in our Python program, we must use inheritance principle. That's why one equation also written. Polymorphism uses method overriding. Method overriding uses inheritance. Hence, polymorphism uses method overriding, inheritance. Inheritance internally using classes and objects and everything. So ultimately, when I'm coming to polymorphism means indirectly we are using all the principles of OOPS. All the principles of OOPS. Did you understand, students? Did you understand? Yes. If you come to this level, today I would like to take it. It is a polymorphism example as well as method overriding example also it is. So I can give you, for you to understand only for the purpose of notes sake, polymorphism example 1.py. Polymorphism example 1.py. Yes, Meghraj, exactly correct. Polymorphism is a combination of all the OOPS principles. That's why when you are entering into the industry, when ultimately we use a polymorphism only. That is the ultimate functionality because it uses all the OOPS principles. Class is there, object creation is there, inheritance is there. Everything is there inside of it. Now, let us go for your place. I will create one small folder. I will write it inside of it. Some sort of, okay, for the purpose of notes, concept purpose, I will write inside of it. Now I am writing the program here. Polymorphism example 1. Okay, student, coming down to the programming part. So G colon here. So I'm saying here, okay, we are Python 6 p.m. and I say, oops, say polymorphism here. Fine, guys. Fine. So coming to the point of it, py, and your example. See that drawing rectangle, drawing circle, drawing square, and etc. And what is the function we are using here? This is a super dot draw. And constructors you take it, students. Regarding the constructors you take it. Of course, that I don't want to go for it. Constructors also I want to show you. Constructor overriding also I will show you. With the parameters also I will show you, students, don't worry. With the parameters also I will show you. Nothing to worry at this moment of time. So coming to the point of it. So this is another example of it, what you are getting it. So polymorphism example 2, this is called polymorphism example 2. So I'm saying that here it is called constructor overloading. One constructor implemented in multiple forms. So let us try to save it. Coming to this, here you see example 2.py. This is what you have seen even in yesterday's class also. And dear students, today we need to understand one important thing. Super.init you are using. Now the thing is, the question is, how we can call the original method from the overridden method? Which function we are using here? Dear students, please answer my question. Which function? Yeah, super function. Super, good. Taushif, Kotesh, Jafar, Meghraj, very good. Super function we are using, right? Coming to the point of it, here we are understanding the discussion called super function. Now there is one more technique is also there. Let me show you that technique for you. It's a most elegant technique. It is. Let me go for it. Let me save this polymorphism here. Let me save this polymorphism concept here, right? So coming to this polymorphism nodes concept, let me save it. Then understand. Yes. No, ma. See, second technique we are going to discuss. Under the polymorphism, we are going to discuss some small information here. Yeah. Approaches. Number of approaches. See, number of approaches. Number of approaches to call. Number of approaches to call base class methods. Base class methods are what? Constructors. Okay. Number of approaches to call base class methods are constructors. We are going to talk about it. Okay. Let us watch this kind of discussion in the classroom. Very, very simple. Very, very simple. Number of approaches to call base class approaches. Now see what is happening here. How easy they are called. To call the base class method, see students, to call base class methods, yes. Yes, ma, you can create, no problem at all. No problem at all. I will show you that also, student. Don't worry. Don't worry. I will show you that also. To call base class methods or base class constructors inside of that. To call the base class methods or constructors from derived class, we have two approaches. Actually, you see in any website, you will find only one approach only they used to say. One approach only they used to say. First one is called super function. Super function they will say. Even I also will say to you super function first. Second function I will tell you with example. With example. Let me take up that example, student. All of you understand me once again. One more point you understand. Coming to this example once again, my dear student, carefully observe it. Second example I am talking about it. Easy, try to understand. Take this example. Which inheritance it is happening? Come on, everybody. Example 3.py. Which kind of inheritance here? Mono. Don't be hurry, ma. Don't be hurry. Multi-level. Oh, shift. Correct. Multi-level. Omkar, correct. Multi-level inheritance it is. Multi-level inheritance it is. It is called which inheritance, ma? Multi-level. Superclass. Inherited into rect class. Rect is called intermediate base class. Intermediate base class to where? Square. It is coming here. Okay. So, what are we doing here? Super dot area, you are saying super dot area. First, remove that super dot area. Once you just observe it. Going to this place, say here, and I am writing polymorphism example 3.py. Polymorphism example 3.py. Let us go to that. Py. Polymorphism example 3.py. Polymorphism example 3.py. See that side 3. I am getting only the square. Only the square answer is coming. Only this square area is calling. This function is not calling. This function is not calling. This function only calling because we are calling only a area method of square. Only area method of square it is calling. Area method of square it is calling. Fine, perfect. Now, my dear student, you are calling square function, square kind of area, want to call this area method. What we used to do straightforward, we call it as a super function of area. We can call it. Well and good. It's very nice. This area method will call it's a superclass area. I will write once again same kind of statement. Super function dot area. We will write super function dot area. What is happening that time? It is calling the area function of the circle class. So dear students, coming to the point back, SO dot area is coming here. Area method of this rectangle is calling the area method of circle. So we are applying super dot area. So see students, all of you, super function dot area. Okay, well and good. Try to generate some doubt also. I want to see your doubt once. See that 36 I got it. So area, sorry, square area is calling rectangle function, 34 and then 5 answer is coming. 170 I'm getting. This area method. This area method I want to call the area method of circle. Area method of circle. Super function dot area. Super function dot area. Then you see side is called 3 and then 12 and then 45 and then radius is called 1.4. We got the answer like this. We got the answer like this. That means if you look at that diagram, here only I will write the diagram. This is called a circle. This is called something like what, something like this. This is called another type of thing. This is called circle. This is called a circle. This is called what, rectangle. This is called what, what is this is called square. So this area method is calling this area method using super function. This area function is calling this area function calling like this. Okay, it is like a step by step from bottommost to intermediate to topmost. But my requirement today is from square class to circle I want to call it. I don't want to call this method. From square area method to I want to call this method. You cannot write like this, guys. Super function like this you cannot write. Super function you cannot write it. You cannot write this statement. First of all, did you understand this? Did you understand this requirement? Please confirm it. Did you understand? Yes. So, to do that type of requirement, we require one more facility. One more facility I want. See super dot area. Here super dot area. Yes, ma, all of you, all the students, Kotesh, Monu, Jafar, Taushif, Saifuddin, Hassan Ali, Lavanya, Akila, Sonali, all the students, name by name, Harsha, Amitabh. Yes, ma, all of you, please confirm it. Did you understand my requirement? Piyush, Megharaj, yes, ma, all of you must confirm. Yeah, here it is calling what? Step by step, like a ladder. It is like a ladder you are calling, like a ladder you are entering, like a step by step you are entering, This is called a circle, this is called a rectangle, this is called a square, this is called a triangle. Triangle to this one, and this one to this one, and from here to here. This is called a super function you are using. You are entering like this. But I want to call triangle, directly want to call this circle. This requirement is giving the important information called second approach. This is called a second approach. Right? From the bottom to I want to come to topmost. Whatever you want, I want to call it. This is number one. I want that requirement, so that I will go to number two. Let me tell you one more thing. Let me go to one more thing clearly. All of you, please observe it, my dear students, please. Here I am taking polymorphism, example 4.py. Carefully observe all of you, because second requirement is so powerful requirement. All of them are powerful only. Class. See, my dear students, all of you. Class. Yes, ma, I'm coming to that. Kotesh, I'm coming to that. You can, that is very simple. Kotesh, that is hierarchical is very, very simple. I am using that. Multiple inheritance I am using. Yeah. See, I'm taking Python. I'm using Python, or I'm going to say teacher one, this is. teacher 1. Okay. There we have a def subject. This is self. Carefully understand. Print of teacher 1 teaches Python. Teaches what subject? Python. Teacher 1 teaches Python. Teacher 1 teaches Python. Okay, finished. Class teacher 2. Class teacher 2. Teacher 2. DEF subject of self. Print of teacher 2 teaches Java. Teaches Java. Teacher 1 teaches Python. Teacher 2 teaches Java. Okay, well and good. How many classes I have? Teacher 1 is separate. Teacher 2 is separate. One more thing I will take it. Teacher 3. One more. Let us take it. Not an issue. Teacher 3 teaches music. Like this. This is called our classes. Class student. Student want what? All subjects you want. Plus music also you want to listen. You want to listen music also. So student has to inherit from how many classes? Say quickly. 3 classes. So I am writing teacher 1 comma teacher 2 comma teacher 3. Teacher 1 comma teacher 2 comma teacher 3. Teacher 1 comma teacher 2 comma teacher 3. Subject student of teacher 1 comma teacher 2 comma teacher 3. How many teachers are there? 3 teachers are there. All the methods are coming to where? Student. There what is happening? Class student, teacher 1, teacher 2, teacher 3. How many methods are coming? Carefully understand. How many methods are coming? Everybody will think that 3 methods, but 3 methods will not come. Mono correct. Only one method will come. We feel that 3 methods are coming, but reality existing only one method, because one memory space only will create. So by default, which method of memory space is creating? That is an important. DEF. What is the method is coming? I want to see students. Look at that. Pass, I will say. Pass. Coming to the main program, students. Main program, you come. Main program, please. Main program. Now tell me. I say SO is equal to what? Student of. SO is equal to student of. I say SO dot subject. SO dot subject. SO is equal to student. SO dot subject. Because of SO dot subject, do you know what is happening? SO dot subject, where it is going? It goes to student, teacher. It goes to student only. It look for the subject. Which subject is given by the preference for the teacher 1? First in, first out. This is called, first of all, multiple inheritance. It is coming 3, same function is available. Same function. Polymorphism I am obtaining. 3 different functions are there. You can call happily 3 different functions, no doubt at all. It is having what function? Same function is available. Which function will be given a first preference by the PVM? Teacher 1 function only will be called. Let us watch this now. Teacher 1 function only. Mono. Listen ma. Teacher, not teacher 3. What Mono is thinking? Teacher 1 function is overlapped with teacher 2. Teacher 2 function is overlapped with teacher 3. Am I correct, Mono? Yes. So, but it is giving the preference for what? Teacher 1. First, whichever is written here, that only will be given a preference. Let me show you the example. Here. Very, very simple, student. Very simple, ma. Polymorphism. Execute this part. You come on to this point. Py, polymorphism example 4. See, teacher 1 teaches Python. Teacher 1 teaches Python. Yes, Shubham, Lavanya. Yeah. Let us coming to teacher 2, you write it. Teacher 1, you write it. Teacher 2, you write it. Teacher 1, you write it. Now you see, teacher 2 teaches Java because it is a first one. Whatever you are writing, first one, that will come only. You write 3, ma. You write 3. This is called 2, you write it. 3, you see what is coming. Teacher 3 teaches music. Yes. That's what, ma, Omkar, I am coming to that. To call that methods properly, what we are doing is very, very simple. Let us coming to that. Yes, whichever is coming first, that will be taken into consideration. Moreover, let me tell you one more importance, ma. One more importance. DEF, whichever one method is coming, I will override. DEF, what is this now? Subject is learning. Self, what is learning? See, printer. What is doing? Practicing. What is practicing? Python. Practicing Python. Come on, next, comma, Java, and what? Music. He is doing that. He is learning all the things. Music. Assume for example. Now tell me what is this is called? Overridden method. I overridden now. See, I'm just increasing the stuff of this code. What is an answer is coming now? SO dot student. What is coming? You tell me. What is coming? Practicing Python, Java, music. Am I correct, students? Am I correct? Yes. Answer, you will get overridden method answer. See, my dear student, practicing Java, this thing, that is, I will write it. Student. Yes. Student, practicing Python, Java, etc. Practicing. Yes, done. Let's go back to this place. I am writing here. Okay. So practicing this kind of thing. Now from here, from this overridden method, I want to call original method. What I am writing, you see, super dot subject. Which super subject will call? Now you tell me. Super dot subject. Which super function will call? Excellent. Teacher 3. Super students. Ma. So giving the super function dot subject, this will be given a preference. See order. Yes, Kotesh. Very simple. Teacher 3. First one is, who is the first one is written? To that will be considered as a direct base class. Others also base classes, but given the preference for this only. Did you understand? Is all of them understand? Yes. Come on to the point of it. See, teacher 3 teaches music. If I write now teacher 1, teacher 2, or teacher 3, if I write it, see what is happening. Teacher 3 teaches Python. Teacher 1 teaches Python. Now, with the super function, how many functions I am able to call? You may ask a question. Sir, I will write a super function dot subject. Again I am writing. Which function will be called? Same function only will call. Same function only will call. And you can see that once again, same function is calling. Teacher 1 teaches Python. It will work, ma. Atul. It will work. It will work. Teacher 1 teaches Python. It will work. So suppose if you write to call the different base class, this is called this one. You cannot write like this. You cannot use like this. Dot subject, you cannot write it. You cannot. Error is coming. I hope, my dear students, super function can call its immediate base class. It's an immediate base class method. Now my requirement is, so super function is having a limitation. Super function can call its original method from its subclass level only. It cannot call Bottommost class cannot call the topmost superclass. Cannot call the topmost superclass. Cannot call. In order to call any of its base class, we have to use the class name dot. Come on, start with this. After this printing, I want to call directly this teacher 3, teacher 2. Directly you call. Come on. Teacher 2, even though it was the last, teacher 2 dot what subject of self, you need to pass it. See students, what is the syntax? Teacher 2 dot subject of self. What is the super function actually? What is the super function actually? Super function dot subject, we used to call like this. This is a syntax we used to call. But here, what is the syntax here? Teacher to class name dot corresponding function name, corresponding method name, and pass the self as a parameter. Any values it is taking, pass the values also. I will see that example once again, don't worry. Coming to that example now, execute this program now. See that teacher 2 teaches Java. Teacher 2 teaches Java. Teacher 2 only I am calling. Now you call what? Teacher 1 dot subject, not subject of self again. Teacher 3, now you say teacher 3 dot what? Subject of what? Self. Now see, all the 3 teachers subjects are coming. Is it understandable? This is an ultimate technique. Is it understandable, students? Yes. So come back to the point back. Here, if you come to this example, what we are having here is super function, and one more is by using class name. By using class name. Let us go for the first one. First one, I will go for it. What is that now? Super function, I will take it. Okay, look at that. This function is used for this function is used for calling immediate superclass function, calling the function of immediate superclass function, that is called a method. Immediate superclass method from subclass method, or if you want, used for calling immediate superclass original method from subclass overridden methods. Subclass what? Overridden method. But it cannot, syntax I will write it. Syntax number 1. It's not only original method, original constructor also I will write it. I can apply to the constructors also. Original constructor from this place. Overridden constructor. See students, syntax I will write it. Look at the syntax. Super function dot what is this? Method name of values, if any values are there, you can pass it. Constructor also same, super. I will show you the example also. Super dot constructor. What is the constructor name? Directly I will write it. Underscore init underscore of list of values. Values if any. I will show you that example also, no problem. This is related to that. I will write it here, but with the super function, we can't call directly with the super function. We can't call directly topmost class method from bottommost derived class. We can't call topmost class method or what? Constructor from bottommost derived class method or what? Constructor. We cannot call. Right. So I will write the syntax here. In legal syntax, this is called super dot method name. This is illegal. It is called invalid. This is invalid. Okay. This also invalid. See students, this is also invalid. Super dot. I will write here. Super dot is called what? Invalid. This is also called one invalid. This is also called invalid. This is invalid. This is called invalid. I hope that you are following. Are you able to follow, students? Don't leave the session, Mark. Don't leave. You must log in tomorrow with the same link only. Same class link what you are using. Same class link only you need to use it. Same link at the same time with what? Same class link, not with other class. Same link only you need to use it. Tomorrow at 7 a.m. you need to use it. So please remember that we need to meet in the class. Yeah. So coming to this, are you understanding this scenario, ma? Is it okay for all of you? Come on to the point of it. Here we are getting this super function, we will use it. Good. So super function importance we understand. It is applicable for calling one function at a time. Let us go to the, by using what name now? Class name. No, Sachin, please understand me. Sunday class, we should meet little early, ma. Little early. Okay, na? So don't mind. So why you want to change the timing, ma? Sachin? Any problem? Any problem in tomorrow class? You want to sleep? Sachin, you want to sleep, huh? Wake up early morning is good actually. Okay. You have some other work, huh? You have some other work, ma? Sachin? So tomorrow for my side, can you postpone it? So first, for my purpose, you please postpone to next. Okay, right. So because tomorrow we need to please attend that tomorrow. It's an important also. At the same time, we will complete tomorrow OOPS related things. Monday we can start fresh timing. Okay, super function we understand. This is an example also we did. Super dot draw. See students, super dot draw. So here square is calling this rectangle is calling this one. So it is not possible to call super dot draw, not possible. Then how do you do that? With the class name you need to take it. Let me complete this requirement with the class name, by using this class name. This is called ultimate. You see students, this syntax which I am going to tell, you never find in many of the websites. Of course, don't feel that I am created, which I find from the PSF documentation, which is a very, very important for you. If this situation is coming, like in our program, this situation is coming, teacher 1, teacher 2, teacher 3, how do you resolve that problem? By using the class names directly. Let me finish it off, then we can do. So with this approach, I am writing, with this approach, we can call any method or any constructor of base class from any type of derived class. It is an immediate derived class, right? Yes, ma, Meena Kumari. Okay, ma. Okay, it is 5:30 a.m. here in Dubai, by 7 a.m. in India. Okay, ma. Okay, good. So, right. I'm appreciating you. Early morning, 5:30 a.m. in Dubai. Okay, very good. You are from Dubai, right? Yeah. I'm really appreciating you because wake up at 5:30 is little very good. Yes, ma. Very good. Nice. Okay. Yeah. See, 5:30, really 5:30 is wake up is really good. Appreciating. Okay. So with this approach, we can call any method or constructor of base class from any type of derived class. Of which class? Derived class. From any type of derived class. Right? So what is the syntax, sir? What is the syntax we are using? We are using, what is the syntax we are using there? See, students, syntax we are using it. What is the syntax, sir? Look at. Syntax is for method level as well as constructor level. Class name dot, we are using class name dot. Method name, we need to take here self. We need to take self is the one you need to write. And values if any. I will show you that next example. That I will show you. Next, one more I will write it. Class name dot, I will take it this constructor also. I will write this constructor also. Here I will write it class name. Class name I am writing dot init of self comma I am writing values if any, self comma values if any, self comma values if any. I hope that you are understanding. Let me go for this example once. See once this example again, this part you take it. This is called something like this. Multi-level inheritance once. Multi-level inheritance. Observe it, all of you. Observe it. Super dot you are using. Example 5. Don't write supers here. This one you see. You execute this. First you execute. See, my dear students. Yeah. Super example 5. Py super polymorphism 5. Only what is this answer is coming, ma? Drawing. Square is only the answer is coming. Drawing square. Polymorphism example 5 is coming what? Drawing rectangle also. Okay, you remove this part. Now you see. Carefully observe it. Drawing rectangle. What is coming? Rectangle. Now it is clear. Square you say, ma, square. SO is equal to, I am changing the bottommost class object created, SO. Now you see the answer. Answer is drawing square. Yeah, very good. Now from this place, I want to call, from this square, I want to call this one, draw function of circle. How do you call it? Is it possible with a super function? Yeah, quickly. Is it possible with a super function? No, it is not possible with a super function. It is only possible with what? Yes, let us. Now I am waiting for you. Yeah, I am waiting. Tell me the answer. Circle dot, statement I am expecting now, statement dot. Circle dot draw of self you need to write. Circle dot draw of self. Beautiful. Circle dot draw of self. So it is coming here. See, without executing this, it is executing. Let us execute that. See the answer now. See, drawing square plus drawing circle. Compulsory question in interviews. Yes. Now, from this square only, I want to call, from this place only, I want to call this one. How do you call it? Two ways are there to call it. One is by using what? Like this you can call super dot what you can say draw. You can call like this. You can call, this is one way. This is one way. See that this is one way. So what is this, ma? Okay, circle. Not rectangle. I will take it, ma. Rectangle. This is rect. I took it. Yeah. Now you see super dot. It is coming. It is coming. You can call it another way also. How do you call it? How do you call it? Rect of, draw of, what you can say? Self. Multi-level inheritance it is. Circle is coming to rectangle. Rectangle is coming to square. Circle is coming to rectangle. Rectangle is coming to square. Execute this code now. Execute this code now. Say this now. See the output of it. Drawing square, drawing circle, drawing rectangle. Is it understandable? Fine. Now, let me pass the values also. Let me pass the values also. Let me pass the values also. Okay. Let me take the values also. Watch this now. I will take separate example. With the values, I will pass it. See how beautiful code we will write it. Polymorphism example 6.py. Example 6.py. Take the same example. Class, circle, class circle. If you understand me, I hope it is written already here. Example 3. Here I will take it. Here I will take it. 1 minute. If you wait, I will show you. Here I will take comma R. R will come from the main program. R will come from the main program. See, parameter I am taking. Parameter I am taking. Specialty today, one parameter I am taking. Calculating area. First of all, are you okay? Is it understandable? Confirm it, all of you. Yes, quickly I want to see. Okay. Next I am going to take class square. I will take square of what? Circle. Circle. Which one is coming? Which one is coming? Same function is coming as it is. What I do there? What I do there? I will take it as it is coming. I will take the parameter called S. I will take a S square. I will take a S square. It is called what? SC. Circle area. SA. Circle area. I will print SA. Area of square. Area of square. Which method it is called? Overridden method. Overridden method. Understand? Area method. Same heading. Same heading. Body different. What, students, are you following? Yeah. Up to this, let us go to the main program. Because if I will enlarge the program, let me go for this. Create what object? SO is equal to square of, square of. Now I'm directly writing, see students, all of you, float, enter side value. Can I write like this? Dear students, can I write like this? Input of, can I write like this, students? All of you, my dear students, right? That value passing to this place. Okay. In place of that 1 minute, I quickly wrote that SO dot area. There I will write it. Yes, students. I forget. Quickly I wrote it. I will write there also. Wait. You see. One more I will write it. Can I write like this? Yes, ma. Yes. Written. Yes, ma. Written. One more bracket is written. Dear students, is it okay? Are you comfortable with this coding? Yeah. Because of this, where it is going? Because of this, where it is going? It will go to area function of which class? Square. From there, after executing this part, I want to call from here. I will write. First, let us see this. Execute this. First, execute polymorphism 6.py. Polymorphism 6.py. Okay. polymorphism 6.py. Yes, see that 3.4 I wrote. I got the answer. Okay, well and good. From here, I want to pass the from here because of this, you are coming here, executing, and from here I will write what? Super function dot what? Area. I will read the radius. Can I read the radius here? So that radius value will go there. Can I read that? Yes, students? Yes, very good. Come on, directly I will write it. Super function dot area of, directly I will write it, float of input of enter radius. Enter radius. Yes, enter radius. See students, all of you. Yeah, very good. You can understand, no doubt in that. Because already we are very good in programming part. Let's start. That's beautiful. Start. Yes. What among? Line number 14. What is that? What is it? Missing. Bracket is missing. Okay. Bracket is missing. Yes, ma. Yes. Written. Enter the side value. Okay, 7.8. I got the answer. See, radius is asking. Beautiful. And I'll say 1.2. I got the output. Am I passing the values or not? This is called passing the function by using what? Super. What a beautiful statement it is. Okay, remove. Once again, enlarge the program now. Enlarge the program. First of all, did you satisfy like this? Did you satisfy the programming of this one? Are you understanding this programming? What I wrote it? Yeah. Now I'm going to enlarge my programming. Look at that. Class rect. I am taking there square, multi-level square. What I am doing there, you see, def area self comma length L comma B. I am taking L comma B. What a beautiful logic this is. L comma B. You see, students, SR, that is nothing but RA, rectangle area, is equal to L into B. Area of rectangle is equal to half RA. Def area self comma L comma B. 40. L into B, area of rectangle is equal to format of RA. Print of 40. Come on to the point. I say here, RO is equal to what? Rect. Okay. RO dot RO. Enter float. Enter length value. Come on. Comma. Enter length value, comma. Again, I will take the same thing. Enter breadth. Enter what value? Breadth value. Yes, breadth value. Fine. Call it. Now see that, students, all of you, execute. Enter the length value 12. Enter the breadth value 13. Output is coming. Beautiful. I am writing in the same line. Area function. Got the result. Such a type of function is going to this place. Now tell me, I want to call this function. How do you call it? Yes, I am expecting super function dot area of, directly you can say here input of enter which value. From this place I will write it. From here. What is this? Super function dot enter what value? Side value. Super function dot enter side value. From this place it is going to rect square. See the output of it. What happens there again? Bracket missing. Yes, see the output. Length is 14, 56. Answer side value 1.2. I got the answer. Beautiful logic. From here, from square, I will call. Which one I will call? This area function I will call. Area function I will call. How do you call it? Same to same. I will call it super dot. Super dot. Tell me. Super dot. Enter what? Radius. Enter radius. What a beautiful logic. Radius. Yes. See, 34 and 12, 3.4 and radius 4.5. Beautiful answer. I got it. Understand, students? With the parameters, I passed it. Are you okay? Is it clear, students? Yes. What a beautiful example. Same thing, I will tell you with the class name, students. With the class name, I will show you. Second syntax, I will show you. Others here, Python, I will pass it. Come on, 7.py, 7.py. Yes, same thing. Don't write this part. Don't write this part. Here you don't write this part. Okay. Now come on. This you call it coming to this place. From here, I will call. Which one I will call? Circle. Circle I will call. How do you call it? From here only I will call it. From here only I will call it, students. How do you call it, ma? Beautiful. Circle dot area of self comma. Quotation. Self comma. See the syntax, ma, once you see. Class name dot method name of self comma values if any. Super. Values if any. Yes, self comma. What is that value if any? Take previous sentence. Enter radius r. Radius r. You take that radius. Okay. Yeah. Float of radius. I will close it. I will close it. See, class name dot. From directly from the bottom of the class. Directly from the bottom of the class. I am going for what? From the bottom of the class, I am calling this area method of circle. Self of, in float of, input of, etc. See that now? See that now? Polymorphism 7.py. Polymorphism 7.py. Out of that, py 7.py. See that? Length 2 and 3. Radius directly coming 2.3. I got the output. What a beautiful logic. After that, I will print. After that, I will print. One more question. What is that? Square. Square dot what? Area. Area. Some self. Same self. Comma. What is this now? Enter side value. Enter side value. Enter side value. Side. Enter side. Okay. Some small line between that, some small line, of course, not necessary. If you want, you can say X, execute. Yes, so 4 and 5. Radius is 4. Side is called 56. 56 square, I got it. Fine. Is it understandable, students? Perfect. So here, we are understanding. Yes, Omkar, you are understanding self, ma. Self you are asking to explain again. RO dot self means what? I told you already. RO means its reference is kept into this. Okay, that is getting this data. In this self same thing from the current class object, from the current class context, you are calling the circle class area method. From the current class, you are calling square of area. Like that, from the current class method, you are calling the other class methods easily. Self, same as previous only, nothing is difficult. Did you understand, students? Yeah, same thing only. Understand, students? Is it okay? Can I show you the same program with the constructors? Can I show you the same program with the constructor, students? Yes, sir. Look at students. Look at students. How easy it is. Let's go see what is happening here. Watch it. Here I am saying 8.py. Here I am writing underscore underscore init underscore self or original constructor. Original constructor. Original constructor. It is called what now? I will write it underscore underscore init underscore underscore overridden constructor. Okay. Here it is called what? Underscore underscore init underscore 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 underscore. This is called overridden constructor. Here I will write it overridden constructor. Overridden constructor. Okay, let us change RO. Here you need not to write this. Here you need not to write this. Directly I will go for what? See the L and B, two parameters are there. This entire thing I will write inside of that. See my dear students. See my dear students, carefully try to understand. A constructor is written. A constructor is written. Directly values I am passing. Directly values I am passing to the constructor itself. To the constructor itself. First value, second value. Constructor. These two values are going to this value L. This B, this is pointing here. Whenever an object is created, reference is going to self. Printing. L and B. Format of this one. Okay. For a few minutes, you just keep a comment. For a few minutes, keep a comment. Execute it. Polymorphism 8.py. 8.py. Yes. Execute py. 8.py. See the answer. 3 and 6. Answer is this. Yes. Go to that. Now I will call this function. How do you call it? Area underscore underscore init underscore underscore init underscore underscore of self. See the syntax once. Underscore class name dot underscore underscore init self of values if any. Yes, we are passing values. Underscore self comma float. Enter radius. Next I am writing circle square dot what? Underscore underscore init underscore underscore of self. Enter the side. Enter the side. Circle dot square dot. I hope students, let us execute it and see the final result. So execute it 1.2. Breadth is 12 and then 34. And the side is called 2.3. Result is like this. Is it okay? So how many ways are there to call my base class method? Base class functions, two things. One is by using superclass. One is super function. One is by using super class name. Which one is having more flexibility? Super function or class name? Second one is having more functionality. This comes under polymorphism approach. By looking at this polymorphism, you are supposed to understand all classes are using, objects are using, what we are using. Message passing is also there. See students, one important point. See the method of the init of rectangle is passing the message to what? Circle. Message is passing. Values are passing to square. Through constructors it is passing. Through methods it is passing. In every moment of our programming, message passing is compulsorily using. Compulsorily we are using that kind of path. Students, are you okay? Is it understandable? Are you perfect? Right, Meghraj, good. Yes. So this comes under polymorphism mechanism. So tomorrow, what is the time? Tomorrow, what is the time? 7 a.m. 7 a.m. Tomorrow's topic is data encapsulation, data abstraction. So that is the first 1 hour. It's a very easy. After that, I will tell you one program by using classes and objects. Database communication also I will tell you with whoops. With whoops, I will tell you database communication also. Okay, na? With the database communication program also, I will tell you tomorrow class. Okay, students? Right. Thank you. Thank you. Good day. All the best. So I will post these examples.